Okay, so we're going to look at using I to rewrite square roots of negative numbers. So I is equal to the square root of negative 1, and we need to make sure we remember that. Okay, that's an important piece. Also, I'm going to use the term PS for perfect square. Okay, and perfect squares are numbers like 4, 9, 16, 25, 36, and so on and so forth. Okay, the reason they're called perfect squares is because you multiply the same base together to get the number. So like 4 is 2 times 2, or 2 squared. 9 is 3 times 3, or 3 squared. 16 is 4 times 4, or 4 squared. I think you get the idea now, right? And that just goes on, continues on forever. Make sure that you're logging this information away somewhere in your head, because these perfect squares, they come into play quite frequently in mathematics, and they could become very useful. So what we're going to do is we're going to first look at the square root of negative 40. All right? The goal here is to take the integer underneath the square root and break it into 3 terms. First term is going to be negative 1. Second term is going to be a perfect square. And third term is just going to be the remaining factor that allows us to create the integer underneath the square root. So, with that, the perfect square needs to be the largest perfect square that will divide the integer underneath the square root sign evenly. Okay, so for negative 40, let me just bring this down. For negative 40, sorry, that should be a 0, not a 6. Negative 40, what I'm going to do is I'm going to break negative 40 into negative 1 times 4, because 4 is the largest perfect square that will evenly divide out 40, and my remaining factor is simply 10. So I have negative 1 times 4 times 10, which is negative 40, all of this underneath the square root. Now, there is a law, or excuse me, not really, well, I guess a law, but more of a rule, that says if I have the square root of a times b times c, that the square root goes to a, goes to b, and it goes to c. So I'm allowed to break apart all the terms into individual terms, okay, all with a square root on them. So I'm going to apply that rule over here. Square root of negative 1 times the square root of 4 times the square root of 10. Well, first off, I know that the square root of negative 1 is simply I, so I'm going to rewrite that as I. The square root of 4 is 2, and the square root of 10, well, that's just going to stay the square root of 10, because if I take the square root of 10, it's going to be an irrational number, which just goes on forever, and we won't be able to write it. So we just leave it like this. So we're done with the problem, actually. The only thing left is to make it look pretty, and the way you make it look pretty is just by putting a 2 first, the I second, and the radical at the end, and that would be your answer. Okay, let me go ahead and do 2 more. I'm going to slide this to the left here so that we still have our perfect squares available to us. Alright, so let's do the square root of negative 48. Alright, so I'm going to break this down. Negative 1. Let's see, the largest perfect square. Well, 48 divide 4 gives me 12. So 4 would work. But if I do 48 divide 9, 9 doesn't work. But if I do 48 divide 16, 16 works. And since 16 is larger than 4, that's what I'm going to use. So there's my perfect square. And my remaining factor is simply 3. Okay, so negative 1 times 16 times 3 gives me negative 48. Now, everything's got a square root over all of it, which means I can then say, okay, square root of negative 1, square root of 16 times square root of 3. Square root of negative 1 I know is I, square root of 16 is 4, square root of 3 is simply square root of 3. I got to make it look pretty, so 4i square root 3, and I'm done with that one. Let's do one more. Let's call it the square root of negative 72. Alright, so what we're going to do, let me just erase these. What we're going to do is we're going to test drive each term over here, 4, 9, 16, 25, 36, and see which one is the largest one that I can use that will divide out 72. So if I do 72 divide 4, I get 18. So 4 would work. 72 divide 9. Okay, 9 works now. 72 divide 16. 16 does not work because it gives me a decimal. 72 divide 25. That doesn't work. 72 divide 36. Ah, there we go. So 36 is my largest number, largest perfect square that I can use. So this is going to break into -1 times 36 times 2. Okay? So there's my perfect square and there's my factor. All of it's square rooted, so I'm going to put a square root on each individual term. -1, 36, square root 2. Square root of -1 is I, square root of 36 is 6, and the square root of 2 stays as the square root of 2. So I just rewrite this to make it look pretty. 6i square root 2. And there you have it.